Cancer.
Cancer.
We're going to cure cancer.
Cure for cancer.
The next frontier in the race to find a cure for cancer.
Cancer is one of the greatest medical challenges humanity has ever faced. It affects every country, every culture, and every generation. Despite decades of research, it remains one of the leading causes of death worldwide. Yet today, science is rewriting the story. This documentary explores how cancer works, how it spreads, and, most importantly, how modern research, technology, and medicine are transforming the fight against it. This is not a story of fear. It is a story of discovery, innovation, and resilience. What is cancer? At its core, cancer is a disease of the cell. The human body is made up of trillions of cells, each programmed to grow, divide, and die in a controlled manner. This balance is maintained by DNA, the genetic instruction manual inside every cell. Cancer begins when this manual is damaged. Mutations in DNA disrupt normal cell behavior, causing cells to divide uncontrollably. These abnormal cells ignore signals to stop growing and resist the natural process of cell death. Over time, they form tumors that invade nearby tissues and, in some cases, spread throughout the body, a process known as metastasis. What makes cancer especially dangerous is that it originates from the body's own cells, making it difficult to distinguish between healthy and diseased tissue. Not one disease, but many. Cancer is not a single illness. There are over 200 different types of cancer, each with its own causes, behaviors, and responses to treatment. Breast cancer behaves differently from lung cancer. Blood cancers differ entirely from solid tumors. Even cancers that appear identical under a microscope can behave differently at the molecular level. This discovery fundamentally changed cancer research. Scientists realized that treating cancer effectively requires understanding it at its most precise biological level. The role of genetics and DNA. One of the biggest breakthroughs in cancer research came from studying genetics. Researchers discovered that specific genetic mutations drive cancer growth. Some mutations activate genes that promote uncontrolled growth, while others disable genes responsible for stopping it. Advances in genomic sequencing now allow scientists to read a tumor's DNA in detail. This enables doctors to identify the exact mutations responsible for a patient's cancer. This knowledge laid the foundation for precision medicine, treatments designed to target the cancer's unique genetic signature rather than using a one-size-fits-all approach. Traditional treatments and their limitations. For decades, cancer treatment relied on three main methods: surgery, chemotherapy, and radiation. Surgery physically removes tumors. Radiation damages cancer cell DNA. Chemotherapy uses drugs to kill rapidly dividing cells. While these methods have saved millions of lives, they come with serious limitations. Chemotherapy and radiation often damage healthy cells, leading to severe side effects. Additionally, some cancers develop resistance, becoming harder to treat over time. These challenges pushed researchers to search for smarter, more targeted solutions. Immunotherapy, turning the body into a weapon. One of the most revolutionary advancements in cancer treatment is immunotherapy. Instead of attacking cancer directly, immunotherapy empowers the immune system to recognize and destroy cancer cells. Normally, cancer cells hide from immune defenses by exploiting natural immune checkpoints. Scientists discovered ways to block these checkpoints, effectively removing cancer's disguise. Treatments such as checkpoint inhibitors and CAR T-cell therapy have shown remarkable success, especially in certain blood cancers and advanced stage tumors. In some cases, patients with previously terminal diagnoses have achieved long-term remission. Artificial intelligence and big data. Technology is now accelerating cancer research at an unprecedented pace. Artificial intelligence can analyze millions of medical records, scans, and genetic profiles in seconds. AI systems assist doctors in detecting tumors earlier, predicting disease progression, and identifying the most effective treatments. Machine learning models are also being used to discover new cancer drugs by simulating how compounds interact with cancer cells, dramatically reducing development time. Data, once overwhelming, has become one of the most powerful tools in medicine. Early detection and prevention. Research consistently shows that early detection saves lives. New screening technologies can identify cancer before symptoms appear. Liquid biopsies, for example, detect cancer DNA fragments circulating in the blood. Vaccines also play a role in prevention. Certain cancers are caused by viruses, such as HPV and hepatitis B. Vaccination significantly reduces the risk of developing these cancers. Lifestyle research further highlights the importance of prevention through diet, physical activity, avoiding tobacco, and reducing environmental risks. Global collaboration in cancer research. Cancer research is a global effort. Scientists, universities, hospitals, and pharmaceutical companies across continents share data, clinical trials, and discoveries. International collaboration accelerates breakthroughs and ensures that treatments improve faster than ever before. Open access research and global databases allow findings from one country to benefit patients worldwide. The fight against cancer has become a shared human mission. Challenges that remain. Despite major progress, challenges remain. Some cancers still lack effective treatments. Access to advanced care is uneven across regions. High treatment costs and limited healthcare infrastructure continue to affect outcomes, especially in developing countries. Researchers are now focusing on making treatments more affordable, scalable, and accessible. The goal is not just innovation, but equity.